Good afternoon, and thanks for joining us for today's Expedition 32 post-spacewalk briefing. With us today, we have Mike Suffredini, the International Space Station Program Manager, Ed Van Cise, the Flight Director, who is in charge of the EVA today, and Kieth Johnson, who is the lead EVA officer for this spacewalk. We'll start off with some statements with our participants, and then we'll go to questions. Mike?
Well, good afternoon. We'll spend a few moments with you today talking about our EVA. It was EVA 18 that we had conducted today with the primary purpose to replace a main bus switching unit on board ISS that was supplying power to the ISS but couldn't be commanded. As you recall, some months ago we uncovered this problem and have been living with it ever since. Again, it was a relatively nominal configuration for us. But we were unable to command it, and there are very few situations where we need to do that on a regular basis. And so we were able to wait until now to conduct the EVA when we were ready and had everything in place. The team did a great job today. This EVA, one of the longest in our history, and the longest EVA, increment EVA that we've conducted since the ISS program began. Unfortunately, today though we didn't complete all of our tasks. We had three main tasks that we had planned, and then one get ahead that was very important to us. The MBSU, of course, was the primary job for the EVA team, but we also had some cables that had to be routed so we could supply power to a new Russian module that's coming up in a year or so. In addition to that, we had a boom camera on the SSRMS that had failed that we had to replace, and then if we had time, we wanted to put a cover on the docking port that the shuttle used to use to keep it clear of debris until we put the new docking system, attached the new docking system some years from now. And as I said, we didn't get all those tasks completed. We did get the cables routed. Unfortunately, in the process of trying to reinstall the spare MBSU, we had some trouble getting the bolts torqued down, and Ed and Kieth will talk more about that after this. But they did a tremendous job. Ed and his team, the engineers and the crew, a fantastic job of working with the box and taking as many steps they could come up with to try to get this thing reinstalled, and ultimately we were not successful. So in the end, we left the MBSU in place. It's partially torqued down, but the power connections are not made, so we are getting no power from that particular MBSU, and then we've tied it down. And in this position, we're in a stable configuration. The box is fine. Thermally, it'll be okay, and we'll decide what to do next and go take care of it here in the near future. In the meantime, the ISS is being supplied power from 6 of its 8 arrays. The team installed some jumpers prior to powering down the MBSU in preparation for the EVA, and those jumpers allowed us to get all power to all the ISS systems and payloads. And so really what the team has to do, they have access, we can get power to all the systems, but we only have 3/4 of the power available that we normally have from the ISS. And so depending on the task at hand over the next several days, the team may have to manage power loads a little bit, but this is familiar territory for the team, and so we'll be able to deal with that while we decide what our next plan is. We do have a number of flights taking place here in the next few days. We have an HTV that's going to depart on the 6th. We have the crew coming home on the 16th of September local time, and then we have an ATV departure on the 25th of September. And so while we think about our plan and when we might do another EVA, if we decide that's necessary, we'll have to take all that into account, move things around in order to accommodate that. But if we do decide to do an EVA, I think you'll see us, if we can determine what we can do to get the MBSU ultimately installed. You'll hear us talking about perhaps trying to do that sooner rather than later in the program. So for the team first, the fantastic job. They did a great job. The vehicle's in a good configuration. We know how to operate without power from 2 of the 8 arrays. But we do have power to all the critical systems, and so as always, the team will sort this out, decide the appropriate plan of action, and we'll go out and take care of this in due time. And with that, I'll hand you over to Ed, who will talk to you more about the specifics of the EVA.
Well, thank you, Mr. Suffredini, and I need to really start off by reiterating the thanks and excellence that our team across the board showed today. We train frequently, not only in mission operations, but in all of our different areas on handling malfunctions as they come up. And even though we didn't necessarily train for this particular situation, it's the mentality that we have grown up with and that we demonstrated on console that gave us all the tools we needed to first try to troubleshoot the bolt issues that we saw. And obviously we tried everything that we could come up with jointly within the ops team and also with all the engineering community working to try to resolve the issue. But as was also mentioned, we have an ops team that is well equipped to handle long-term off-nominal situations if it has to. If we don't have all 8 power channels, we know how to work with those resources. And as was mentioned, we're really not in a posture that the redundancy is compromised on board the vehicle, but just a matter of which facilities and which operations we want to do at a given time with the amount of power that we have available. So while it's not ideal that the situation that we're in right now, it's certainly not one that leaves us in an off situation that we can't keep moving forward. As far as the EVA itself, we got the crew up right on time. They went through their EVA preparations without any issues. We got out the door also right on time at 7:15 local, and didn't work any suit issues throughout the day. And we were also successful in getting the cables routed, and that was one that we also needed to track pretty closely. Obviously, we ran into issues with the bolts themselves on the MBSU, and that took most of our attention throughout the rest of the EVA. We did get the failed box, though, installed on its stowage platform behind the airlock and got that covered back up with its thermal blankets, so we have that piece of hardware fully secured, which only leaves us with one problem to go finish resolving, and that's the box that's sitting out on the S0 truss, not fully installed yet. But the team did a great job at the end as well. An EVA, obviously this long, not only takes its toll on the crew and having to work the length of the day that they had to, but also the integrated team. And I never saw anything that would give me any indications that I had to worry about their capabilities or fatigue. They did an exceptional job. We got the crew back inside safely. We absolutely know our configuration that we're in, and the teams are already talking about how we might go resolve the issue and get things squared away on board to support all the operations that Mr. Suffredini mentioned and get us back to operating the world-class laboratory that we have on orbit. As far as the operations go, that was pretty much the highlights of our day. And Keith, I don't know if you have anything else to add about the bolt failures that we saw.
Thank you, Mr. Van Cise. Let's see. So first of all, we were fortunate that the crew used the in-suit light exercise pre-breathe protocol this morning. They got out the door, as Ed mentioned, in a timely fashion, and also we were able to change out their contamination control cartridge, which provides them the CO2 scrubbing capability, and we installed new ones with 40 minutes of pre-breathe left, and that allowed us to have the extension time available to do the troubleshooting that Ed mentioned. During the EVA, we did have one suit issue that we began tracking towards the end of the EVA, where Aki's temperature started rising. It stayed within limits, and he got the cooling he needed, but we'll have to look at that suit afterwards to determine if it's go for EVA again. During the EVA, the bolt issue that we've been talking about, I brought some hardware along with me. Off to my side over here, this is what we call a stanchion bolt, the H2 bolt, and the bolt that drives into it over here is on the MBSU itself. And this bolt here drives the box down into the configuration that it needs to go in. On our first attempt, we drove the bolt quite a few turns, but not the sufficient number to get it all the way seated and the electrical connectors mated. And as part of our troubleshooting, we backed the box back out again and tried to inspect it. And during the inspection, we noted that There was some fragments inside of the housing itself, and we decided that it probably was prudent to clean the work site out. So we went back to the airlock and retrieved a pair of pliers. We went back for a different socket and found that it wasn't in the airlock as we expected, and we're going to have to do a team to go look and find out where that particular socket is. We did find a pair of pliers. We brought it with us to the work site and used that to dab around, and we found that some material came out of the socket when we did that test. And we tried to drive the bolt again with no success, fewer turns this time. When we backed it out, we retrieved what's called a connector cleaner tool, and I have a picture of that. This is a gas canister that holds nitrogen. I don't have the exact pressure that it's in there, but it gives us about 10 seconds worth of a burst of gas. Sonny Williams injected that down into the receptacle on the socket and depressed the handle, and it sprayed nitrogen gas down. She noted that more material came out of it at that point. We then decided that it probably was prudent to spray the bolt on the MBSU itself. And again, when we did that, I'm at the wrong end there. That's the bolt down at this end. When we sprayed, more material came out. Back at this end, this is the bolt that the crew members drive. We attached what's called a torque multiplier on this particular interface, and that increases the torque that goes into the bolt that the pistol grip tool can supply. When that happens, there's an indicator. It's located over here that shows us the locked and unlocked configuration for that particular bolt. The troubleshooting that Ed mentioned, we tried this several times. Our last attempt, it became bound, and we just, at that point, decided the best approach was to leave it where it is, do additional troubleshooting on the ground, and come up with a workaround plan that Mr. Suffredini mentioned, and we'll put in place and try here in the near future, or determine if there's a better course of action. So that's all I have.
Okay, with that, we'll start our questions. We'll start here in Houston. Mark?
Thanks. I'm Mark Carreau for Aviation Week. I have a couple questions, and I just want to be clear on how the box is now fastened to the station. And if I understand it right, one bolt is holding it to the station, and then it's lashed with a tether to the handrail. So it's secured that way, is that?
Well, we come up with a plan pre-EVA where conditions like this, if they arise, we come up with a safe configuration that restrains the bolt with a tether. And what we have is a long-duration tie-down tether. It's designed specifically to hold the box in place for long duration. We have a tether point on the box itself and the tether point down on station, and we do this for all the boxes that we intend to remove and replace. We come up with a method of doing this. It just so happens that the bolt is now partially driven in, so that's additional restraint, but it is not the correct configuration of that box.
So could you talk about what's affected in a power sense when you're in, when you have 3 main bus switching units, what some of the trade-offs are that you might be working in the next day or so in terms of providing power, and whether it influences communications or life support or research, or just what you have to sort of sort through to take care of the priorities.
Yeah, absolutely. I guess just to provide the clarification, so we have power to the subsystems of the space station from 6 of our arrays, but all 8 of the arrays are of course still operating and still fully functional. The 2 arrays that we're not pulling power from, it's 1A and 1B are what we call them. They are still charging their own batteries, and there are systems out associated with those solar arrays that still need maintenance, and those arrays are still providing the power to do that. So just to clarify that if there was a question there. With the subsystems inside and outside the vehicle that are not related to their own solar arrays, we are down to 6 power channels to provide all that power. And we have flight rules in place that give us a maximum loading of kilowatts per channel. and that's what we work to balance across the channels that we have available. The space station, now that it's fully assembled and operational, it actually has a lot of flexibility to route power around through different means. So we can be creative with how we share, we call it share ratios, but how we share power across the power channels to be able to provide as much balance as we can across them. But that said, there are some things that do require more power and are only connected to certain power feeds. So for example, the space station arm, the SSRMS, when it's in use, does draw power. And so one of the things that we have, if we haven't done it already, we'll be doing tonight before they go to bed, is they will disconnect the robotics workstation in the US lab so that that piece is not drawing power off of the power channels that are highly loaded. So we take actions like that to turn off equipment that aren't necessarily required to make the most power available to put in other places. Another tactic that we'll use is we normally have shell heaters for all the different modules on such that they can turn on themselves if needed, so they just run on their own thermostats. We might instead go to a manual shell heater operation to where we are selective on which shell heaters turn on so that they come on using the correct power channel. But it's really, on a bigger scale, we're just balancing the loads across the 6 channels that we have without minimizing or reducing our operational redundancy we need to actually go fly the vehicle. You also mentioned payloads, and that is going to be something we're going to have to look at. Obviously, we want to keep doing that world-class science that we do. We just have to be smart on which facilities we have up at a given time so we don't have 2 facilities that use a lot of power on the same feed.
Any further, Mark? Okay, we'll go to our phone bridge questions. We'll start with Marcia at the Associated Press.
Yes, hi. I'm wondering what's the earliest you think a spacewalk might be held? And I'm wondering if any of the 3 of you, would you characterize this as an urgent situation that needs to be remedied, or how would you talk about that?
Okay, I'll do it. Let's see. There's an advantage to going outdoors here in the next little while Joe Acaba is still on orbit for us, because he's the arm operator, and the team's got all the experience they have now with having worked on the NBSU. And so the urgency really is not about the configuration of the ISS or the condition the NBSU is in. It really is, if we wait too long, we have to do retesting of the EMUs. We have to do some checks of the different systems that support the EVA. So if we can figure out a plan that requires us to go EVA to go solve this problem in the near future, the advantage to us is saving crew time and getting ready to go outside, and the crew's immediate experience having already dealt with this for some time. But from a system perspective, we're stable and in good shape. We actually, with this reconfiguration, we actually do even get some redundancy back. And so I would tell you, this is not a configuration we want to stay in for a long period of time, but even in this configuration, we're robust to many failures still. And so in that respect, we're not rushing out the door to try to hurry up and fix it. We're really trying to take advantage of our experience and the crew that's on board today. Also, with the flights coming up, the HTV departure, and then ultimately with the Soyuz departure, these, of course, are critical operations, and so we'll have to look, if we want to try to do this sooner rather than later, then we'll have to look at those 2 operations. The HTV from the standpoint of, do we have to do it right now, or can we maybe delay it a little bit till after Joe leaves in order to get that work done. Now, we're not entertaining asking the crew to stay on orbit longer, and so using that as sort of a constraint, we're just trying to see if we can figure out a plan of attack, if we can get it done before Joe departs and while the systems are still configured for the EVA to minimize the impact and crew time to research.
Thank you. And what is in your mind right now, subject to change, of course, what is the earliest you could expect to go out? Would it be Labor Day, Monday, Tuesday, Wednesday? Do you have any clue as to when might be the earliest?
I don't know the answer to that. Of course, we got to get the crew rested, and we got to figure out what we're going to do. And that's probably the biggest thing. We need to, the teams have been working all day today to try to get this thing installed, and so now they're going to have to step back, and we'll have to go get the qual unit of the heat exchanger, which has the post on that Kieth showed you. We'll go get the qual unit for the MBSU. We'll take those out in probably building 9 somewhere, and we'll try to look at what our options are and what we can do. We'll have to look at the build paper for the S0 to see if we had anything happen during the assembly that would help us understand what we're dealing with. We have to look at other techniques. So I would tell you, Marcia, the long pole in the tent really for us is going to be, can we figure out things that we could do to try to recover this? And by the time we've done that, we've talked about it, we've generated procedures, we've run through those procedures together and potted those procedures. I think that will be the driving force, and by that time the crew will be rested and we'll have a plan in place. So I would think that if we can, we try to get outdoors early next week if we can come up with a plan. Again, I think that's the biggest driver, is knowing what we do. Having worked it enough to feel confident that we have, plan A, plan B, plan C, and plan D potted, so we can get out there and be productive when we do finally go outside.
Thank you very much.
Okay, next we have Bill from CBS.
Yeah, hi guys. Maybe this is for Kieth or Ed. I'm not sure. I'm a little bit confused. Is the bolt jammed right now? In other words, is it jammed on the post, or can you get it off? That's my first question I'm confused about. And secondly, is it even possible to jumper this thing outside if it came down to that? If you could never get it to drive down on the post like you want it to, are there possible workarounds with cabling or whatever to get around that?
Well, to answer the first part of your question, the bolt is jammed right now. I don't remember the exact turn count that we got on it, but we did drive it with the torque multiplier that Kieth explained, and drove it as far as we could before the tool torqued out. We did that, however, such that we could still be able to get it back out if and when we need to. So we were very methodical in our approach, so that we always had a known setting that we could use to back it back out. So you saw us backing out several times today, and the torque that we went into the bolt the last time, there's still a torque setting with that torque multiplier that'll allow us to get it back out. So it's not jammed in there such that we can't go either direction. We did leave it with it jammed in, I'd say probably 4 or 5 turns on the bolt, and then with a long duration tether that Kieth mentioned. As far as jumpers to go between the S0 truss and the MBSU, for example, we don't have anything like that right now. It doesn't mean that creative people on orbit and on the ground couldn't come up with solutions. So as of right now, we've only just begun to start talking about what the different options might be. Of course, we want to really resolve the issue and get the box fully installed. But part of that, of course, will spin off, I'm sure, discussions about, well, what happens if we just can't, and what is our long-term solution going to be? And with the creativity that there is with people around here, and if we have the materials on board, there could very well be a possibility, but we haven't had any of those discussions yet.
Well, can you give us any idea of what sorts of things might be done to get this thing fixed? I realize you don't have an answer yet, but I'm confused, I guess, enough to have any idea what might be possible. Thanks.
Well, let's see. Obviously, the go straight at it approach was tried today. We tried multiple torques of just driving it in, multiple torques of driving it out, wiggle it this way, wiggle it that way, cant it in different orientations. So those were all the easy, maybe not so easy, but the lowest hanging fruit to attempt. So really the first thing that has to happen is we have to, like Mr. Suffredini said, go back and look at the vehicle, go look at the design and see if there might be some tricks in there that we can use to use the tools to just actuate that bolt. Kieth mentioned the connector cleaner tool. I believe we have additional capabilities with similar tools like that to possibly clean out the S0 side and the bolt side. So people will be looking at that. There's a lubricant. I'm sure you heard the bolt threads and the receptacle threads were lubricated. People, I'm sure, will be looking at that and see if there might be something we need to do in the ways of lubrication to make things turn a little bit more easily. And that's just off the top of my head, trying to come up with things that people are going to look at, and I'm sure we'll go even deeper and further to come up with, like you said, plans A through D.
I will mention a couple other for you, Bill. You have to keep in mind it's a blind mate connection. So when you talked about the jumper, when the MBSU comes down, not only are the electrical connectors connecting, but the fins for the cooling system are interlacing with one another, and we have to have that interface in order to keep it cool. So the idea of a jumper is very difficult because you got to get in there and try to get the jumpers between the blind mate connection and still get the box down, but you can't get the box down because the screw won't screw down. So we really can't operate in a configuration where the MBSU, at least not at high loads, where the MBSU is not connected to this heat exchanger. So that's one of the issues. And so some of the things we've talked about while Ed was busy doing his day job back with the engineers, we talked about is there a way to either remove the post itself or remove the screw from the MBSU in order to get it down and let just the other bolt, what we call the H1 bolt, hold the MBSU in place and maybe add a strap. It turns out both of those are kind of difficult, but the teams, those are two other options the teams are off to look at. We'll look at whether or not we can go higher on torques if we change techniques like Ed mentioned. We also are considering whether the SPDM can be utilized and whether or not as a robot we can apply forces on it to help it go down. All of these things are being kicked around, and I assume starting tomorrow the teams will have a whole list of other things, as Ed said, as possibilities that we'll sort through to see if we can get this thing installed.
Okay. Anything else, Bill? All right, then we'll go ahead and move on to Elvira with the EFN News. All right, not hearing anything. Todd, with Florida Today.
Thanks. Todd Halverson of Florida Today. For anybody who wants to take it, I'm wondering if somebody can explain in real layman's terms why you would not be able to, drive a simple bolt, something that everybody does in their garage. I suspect it has to do with thermal conditions in space, but perhaps you could elaborate.
Who wants to take?
Gosh, I guess if we knew that, we'd have it bolted down by now. It can't be cross-threaded. It's an Acme bolt. It's a very big square-threaded bolt. But bolt galling is a very common condition, which you may or may not have experienced in your garage. Most of us shade tree mechanics, and I count myself as one of those, I've cross-threaded a bolt or two in my life and galled a bolt or two in my life. And when you do that, it's your car, and you're only marginally worried about your success, and so you just get a bigger torque wrench out and you hope you can get it down. But really as an ops team, we can't do that. So we have to worry about, there are conditions where you can gall bolts and then not be able to move them. And in this case, if we had done that with this particular box and gotten it half on, we'd be in a really bad spot. So part of it is we don't just get the biggest torque wrench out and try to really kind of lean on this thing until it starts to move or the bolt shears off, because that puts you in a much worse position. So it's got to be a combination of some version of galling. Perhaps we assumed it was associated with how the box goes down. As we said earlier, as the box comes down, you've got one bolt driving first. In fact, we didn't start pulling down on the other bolt, which is a little shorter, the H1 bolt. The H2 bolt's got to get you down, and then you drive the H1 bolt. Well, while that's happening, you're eventually going to come down and settle on the fins, and there's a whole bunch of fins small fins that meet each other, and then you're going to have the connection over here. Well, in the process of doing that, you're trying to make sure this box is coming down square, and so we assumed eventually, after we pulled the box off and confirmed that the bolts didn't look galled, and that's kind of a hard assessment to make outside, but it looked like it wasn't galled, and after cleaning it up, we thought maybe it was a technique thing, and so we started down this technique path of trying to get this box settled down. So somewhere in there, you're either dealing with contamination, you're dealing with, we're getting it a little cocked, and that's making it hard for us to drive the bolt. Maybe the bolt is galled. That's one of the things we'll have to talk about. Can we recover from? Maybe is a thermal difference, and for some reason the bolt's a little bigger than the socket, but we go to great pains to make sure that's not the case when we do tolerances before we fly. But we'll look at all these different options to see what's keeping us from getting this bolt down, and see if we can find a path that'll give us the additional force or oomph we need to get this installed without actually damaging ourselves, damaging it to the point that we can't ultimately remove it and get a new one on. Again, as you recall, we pulled this off. When we pulled the old one off, we noticed the contamination, but we looked at the bolt on the failed unit that came off. The bolt was in good shape. We went and installed it in the FSC, and other than trying to get it positioned down there and torqued down, it went in okay. And so right now we're not assuming that we're dealing with a completely damaged socket, or that we're not dealing with a bolt issue on the spare. Otherwise, we could go get the other spare and install it. But that would be one of the things we'll talk about, is whether or not we think maybe we did something to the spare in the process of trying to get it installed. So all those things we're going to have to talk about to see where we think we are and what the path through the wilderness will be.
Thanks, Mike.
Okay, on to Pat with the German press agency. All right, Denise, space.com.
Hi, thanks. I think this question is for Ed. I'm just wondering if you're still thinking, or if early assessments lead you to believe that there might be some debris still stuck in the bolt housing, and if so, was that likely caused when the bolts from the faulty unit before were being removed?
Well, as Keith mentioned, we did two different methods of trying to get FOD out of the S0 receptacle. The first thing that we did, when we pulled the MBSU out for the first time, we had Sunny Williams go look at it, and she did tell us about the little bit of FOD that she could see. And based on that, we went and got the needle nose pliers out of the crew lock and had her put that into the receptacle to try to get the debris out of the area. We attempted installing the MBSU, as you know, and didn't have luck, so we got the connector cleaner tool. And with that, we shot a couple puffs of nitrogen in there, and she reported that she did see more debris coming out. And after that was complete, she looked in, and as far as she could see, there was nothing left inside the receptacle. So we're fairly confident, for at least the best that we could see, that there was no debris remaining inside the receptacle when we went to install it this last time. Now, it doesn't mean that there, of course, isn't debris generated now based on the efforts that we undertook and ultimately torquing out the bolt. But when we went to install it the last time, at least as far as we could see in the best of our ability, we were clear of FOD. And we also inspected the bolt and gave it a couple of puffs of nitrogen as well to get anything off of the bolt that we could liberate.
Thanks. And as far as I know, it wasn't possible, or pictures just weren't taken of the work site. Does that pose a challenge, not being able to directly see what's going on, or does it not really matter because you have the building plans for all of these components anyways?
Well, we did actually have the helmet cameras from both Sunny and Aki, so we were able to get pretty good views. But of course, the resolution that we would need to actually be able to see inside the bolt is something that we just don't have on those cameras. We did have the crew take still pictures, however. The very first time that we got the failed MBSU out, we had Sunny take some still pictures, so we know what the situation looked like before we attempted any cleaning and before we attempted installing the spare MBSU. And then also, as we were leaving the work site, we had Aki use his camera to take some more pictures of the work site, and of course that's with the MBSU installed as we have it right now, but at least we have good, clear indications of what the work site looks like. We were also getting great verbal cues from the crew. They were telling us the separation distances between the hardware and the truss, for example. They were telling us what the status indicators were doing that Kieth mentioned. So based on their verbal cues, we were also, I feel confidently well aware of what was going on with the situation in the work site.
Great, thank you.
Okay, and I think our last caller is Irene Klotz.
Thanks, Kelly. I have a few different questions. First of all, could someone just describe the dimensions of this bolt? And also just, I'm having trouble getting my head around this. Neither the H1 or the H2 bolts are currently engaged. Is that correct?
Well, as we mentioned, the H2 bolt is the first bolt that we drive when we're putting the box in, and so all the troubleshooting that we did back and forth allowed us to get at least a few turns into the H2 bolt. So that is driven probably on the order of 4 or 5 turns. The dimensions, the box itself is probably, you know, I would say on the order of probably about, I don't know, 60 centimeters by about 40 centimeters by about maybe, I don't know, a foot deep. I'm changing, you know, units here in the middle of this thing. But the bolt itself is a pretty good sized bolt. I can't really, it's hard to show in what I have here, but it's a pretty good gauge bolt. It's sturdy. It's used for launch loads and holding the box in place during that, and then again when it's on orbit. So we could probably provide you with information on all of those dimensions, but I don't have them here.
Oh, okay. You can't just like estimate the diameter of it, like there's something that you can think of as an altitude of the diameter.
I don't know if somebody can zoom in on.
No, show them the size of the hole on the. That'll give you some sense of the size.
Okay, well, to give you a gauge, this is the bolt right here, and I'd say probably on the order of, I don't know, 1/2 inch to 3/4 of an inch, and it drives into this particular hole right here. So if that gives you any indication, the torque one of the things that we prepare for when we're installing a bolt like this is, as Ed mentioned, we changed the torque, stepping it up and increasing it each time we tried to drive the bolt. There is a failure threshold that we work towards, and so we want to make sure that we maintain a torque that will not shear the bolt off, and that creates all kinds of other problems. And so part of our troubleshooting and what we want to do and maintain is not actually causing irreparable damage, such as breaking a torque. So the torque value that this particular bolt would shear at while driving it in is something on the order of 63 foot-pounds. So we keep that in our scope as we're increasing the torque and using the tools to drive it. We could well exceed that with the tools that we have, so we have to be very careful in how we approach driving the bolt.
Thanks. And how many spare units are currently on the station? And have you? I can't remember if this has ever been replaced before.
So I think we had, so you're catching us all cold because we have so many spares on orbit now. I believe we had 2 MBSU spares on orbit. In fact, we're fixing to fly one here in a few flights. But I believe we had 2 spares on orbit. So we were about to consume this one, and so that would leave us with 1 more. And then I believe the next HTV flight was going to bring up another spare MBSU as well. So we do have plenty of spares.
And then the last question I had was about the science impacts, if any. I wasn't very clear about why why you'd lose to use the power availability of 2 of the arrays with this unit not connected, and if you did power down anything, even today or yesterday, in preparation for the replacement of this unit? And in particular, I'm interested in AMS and any other of the kind of very high-profile experiments. Thanks.
Well, as far as the power downs are concerned, of course, the MBSU itself, we have 4 MBSUs operating on the vehicle, and each of them takes the input from 2 power channels, and so you've got 2 inputs, and distributes them across multiple different output feeds. And we route that to all over the truss segments, then to all of the laboratories, and we send some of that power back to the Russian segment as well. And so that's what the critical function is that these MBSUs provide. So when you take away a quarter of the capability, and that specifically is the 1A and 1B power channel feeds, we have to make do with only the 6 remaining power feeds coming out of the other MBSUs. And of course, everything on board the vehicle uses power, so we have to do a balancing act with that power. And our research facilities use power just like everything else. And again, it's at this point, getting ready for the EVA, we went and made a specific power down plan so that we could keep all of our necessary redundancies with these jumpers installed. We could keep the heaters off that we didn't need to be running, and basically make sure that we were in a good power posture for this day. Now we just need to continue that through the next several days until we get this issue resolved. And we have a great team, a power resource team, and that is their primary function, and they are exceptional at it, to looking at all the different resources that are required. And so what will happen is for any given day, all the users of power, so you've got your core systems that need just a given set of power. You have your core research facilities that are always on, for example, AMS being one of those. And then you have the periodic loads, be they the space station robot arm or a specific payload facility that needs power at a specific time or for a specific day. All of those will go into the power resource officers, and they will lay it out onto the maps of what's predicted to be our capability for that given day. And ideally, we'd like to accommodate everything, and sometimes that doesn't work. And now that we only have 6 of 8 power channels, we have to be a little bit more constrained in what we can manage. And what that might mean is that if a particular payload wants to do science on Wednesday, with some other activities also occurring on Wednesday, they may have to accept doing it on Thursday instead, just so we can keep the power balanced. So as far as capability for doing research, the ongoing research will keep going, and it's just the periodic research that we pick and choose to do on certain days will be a little bit more constrained on potentially, just given on what our capabilities are for that day, whether or not they'll be able to operate. But we're not looking at needing to shut down any of our key research facilities, not the AMS or any of the others, and we will be able to continue doing all the research. It's just a matter of being able to schedule it.
Thanks very much.
Okay, we skipped over a couple of folks that were on the phone. I want to make sure none of them rejoined us. Okay, and any follow-ups here at JSC, Mark?
Mark Carew from Aviation Week, and I think these are pretty quick questions. I just want to make sure, though, that I understand the 4 MBSUs were fitted onto the truss before it was launched, so S0 came up. And from your demonstrations, the bolts are integrated into the truss and the MBSU. It's not like you can go get a spare bolt somewhere. You really have to work with what you've got. Is that the sense of it?
All right. Well, with that, I want to thank everyone for being here for today's briefing. Here at the Johnson Space Center, the newsroom will continue to track the progress of the team as they work on the issues that occurred today, and we'll be providing all the updates on the internet at the NASA website at www.nasa.gov/station. With that, we'll close the briefing. Thank you for coming.